All right, here's your very first truth table problem in chapter 7, interactive truth tables, set number 1, problem number 1 in section D. So when you see a truth table, they're all set up in a standard way. First, you've got the 3 simple statements listed here on the far left, and their truth values are set up in a way that guarantees in a standardized form that we have every possible combination of truth values represented. Okay, so on line 1, we're going to look at whether this compound statement would be true if all the simple statements in it were true. On line 2, we're going to look at it if W and S were true, but then Q was false. And so this just runs us through all the possible combinations. And there's a specific formula for how that's set up, which we talk about in the chapter. So when we come over to this side of the truth table, the truth tables for the individual simple statements have been carried over from this column and listed in like a light color underneath each letter. That's just for visual ease so that you can see them. You don't have to keep looking back to the side of the chart. So what we have to do is we have to figure out the truth values of the logical connectives. That is the symbols that join together and determine the relationships between the simple statements. So here we've got dots, right? So we've got W and S and Q. That's what this says. The dots are and statements. So first we want to determine the truth value of this dot. Now, why did I start here? Because as a general rule, you want to start as far inside of whatever parentheses are there as you can get. Go as deep in there as you can. And then you're going to work your way out from there to the main operator. Now, the main operator of the entire compound statement is never going to be inside parentheses. Okay, so in this case, this is the only logical operator that's outside of any parentheses. So I know that that's the main one, and it's going to be the one we get to last, because I can't determine this truth value until I determine the truth value of this whole compound statement, which is inside the parentheses. So let's start there. Now, we'll start on line 1. If W is true and S is true, then is it true that W and S are both true? Why, yes, it is. If you look at the truth table definition of the conjunction, that is the dot, you will see that the dot is true whenever both of the conjuncts are true. If either one of them is false, then it's false. But if they're both true, it's true. So we've got true on line 1. What about line 2? That's also true. On line 3, S is false, so the dot is false. And so also on line 4, line 5, line 6, line 7, line 8, because there's a false in at least one of the conjuncts. All right, so now we're in a position to determine the truth value of the whole compound statement, that is the main operator. So we've got a conjunction sign, a dot. So that's going to be true only when both of the conjuncts are true. Now it's easy to see this conjunct that's under the Q, but what are we looking at? Which column should we be looking at over here on this side? Well, we want to look at the dot, the column under the dot. Why? Because we're looking at what this says is not just that S and Q are true, not just that W and Q are true. It says that W and S are true, and Q is true. So it's the and which determines the truth value of this whole compound statement, which is inside the parentheses. This is the truth value of the whole thing inside the parentheses. So that's what we're looking at. Okay, so on line 1, we've got a true and a true. So the dot is true. On line 2, we've got a true and a false. So the dot's false. On line 3, we've got a false, and actually all the other lines have at least one false under the dot here. So I know that this dot is going to be false, because the dot is only true, the conjunction is only true when both conjuncts are true. So that's how we solve that truth table. That's what it looks like.